In this video, I will be demonstrating the very basics of using SiteNET, the program that is essentially a surface building tool. Now, this program operates based on two key requirements. One is that it is layer-based, meaning that you will put entities, CAD entities, on layers that are to be considered for either the design or the existing surface. The other aspect to that is that all of those entities on those layers must be elevated to be used as a surface model. So entities at elevation 0 will not be used. For this example, I'm going to use this very simple site layout that contains a building, some parking areas, and an access road. As I said in the introduction, all entities must be elevated to be considered for a surface model. For the existing surface, I have points and break lines which are elevated. For the design, I only have two-dimensional lines and polylines that will need to be elevated. I will be using in this demonstration a handful of Carlson tools supplied in SiteNet to elevate those 2D entities into 3D design elements. Now, throughout this demonstration, I will be using the 3D drawing viewer to examine entities as I draw them. Now, to take a look at what we already have, you just simply select the entities you'd like to view, and you can see that the design elements, the parking lot, building, and access road, do not appear because they are not elevated entities at this time. So to get started, we look through the layer surface library, and you will see that all the layers in the drawing show up under a tab called Other. There is also a tab for existing and a tab for design, which have no layers in them yet. So we're going to move layers from the other into existing to start with. So I select the points layer, and there's a drop down for existing or design, and I just click Move To. And if I go back now and take a look at the existing tab, the points layer is in there. Now, a shortcut to accomplish the same thing is to use shortcut tools, which are in the form of icons of set layer to existing. There's also a set layer for design and a set layer for other. So if I just click on set layer for existing and then select any one of the polylines that are on that break line layer, it enters that layer into the layer library. So if you go back and look now, the existing has both break lines and points in it. If your existing surface was in the form of a tin, was created previously by survey or supplied to you, you just simply change the surface source from layer to file, then select the existing tin for your existing surface. The next step, I am going to create a boundary around the work area, which is another requirement of SiteNet, is to have something to define the limit of work, and it's just essentially a closed polyline around the area that you want SiteNet to consider. I'm going to use a command called shrink wrap entities to draw a polyline around all the points and data that I'm using. So I select across gaps because there are gaps in between the points. Also going to select a layer for the boundary line to go on. And I like to have a construction layer of sorts, a design layer for entities to go on that I use specifically for creating the surface model that may not end up on the final design plan. So I'm going to select a layer called General Design or GN-Design, and I will be drawing the boundary line on that layer. Perimeter reduction value of low, medium, or high specifies to what extent the program will jump the gap. So a really low setting will jump a larger gap than a really high setting. I'm going to draw a 2D polyline, and I hit OK. And simply window in everything. When I hit return, I now have a polyline around the perimeter that I'm going to use as my boundary line. So to make use of that polyline now, I click Set Boundary and then select that polyline that I just drew. Once I've done that, I am ready to create my existing surface model. That is accomplished by simply hitting Make Existing. And just like that, the surface model is created. It is saved externally on your hard drive. And now to be able to make use of it or take a look at it, we can use Surface Viewer and select one of 3 brand new tins that were created. So just to back up a little bit and take a look at these 3 tins that were created and why they were created, I'm going to go back into Project Settings under Carlson Configure and take a look at the Takeoff SiteNET settings. And there is a list of the surface models that get created. Each surface model is named automatically. -OG is for original ground, and then there's after zones and after topsoil. And these surface models are used by the program to calculate volumes and material quantities. So in this demonstration, we'll not be making use of those because we're not going to identify or define any subsurfaces, but that's what they're used for. So if you were to say that the site had 6 inches of topsoil or something like that, it would use that to calculate those different quantities. So now we can go back and take a look at the surface viewer, and I'm going to select the original ground. Now the other 3 at this point in time are exactly the same, again, because we have not defined any subsurfaces at all. But out of practice, I will continue to use the original ground to view. So I select that, and I have a surface file viewer that looks very similar to the dialog box, the drawing viewer. This is actually looking at the surface model itself. You have a wireframe, you can shade it, you can add vertical exaggerations, but what we're looking at here is starting to think about the surface model itself and not just contour lines for the purposes of designing. If and when you do want to take a look at the contour lines, they are a product of the display settings. So you can open up the display settings and simply click on the existing contours, and when you hit OK, they'll appear on the screen. So they become a toggle instead of a design tool or part of the surface model itself. They are just a graphic example, which of course what contours are. The same goes for the design. And if you want to control the layers, there are a tab in toggles that you can go in and set whatever layers you want your contour lines to be on. You can leave them off during the process of building the surface model. Now that the layers are set for existing in the layer library, you can use the layer toggles and turn on and off layers by clicking on either existing, design, or other. As you can see, you can turn your existing on and off so you have a clean screen to work on when you begin your design work. Now I'm going to start elevating the design entities by setting to my design layer, my general design layer. I'm going to start with the building and use a copy layer command and select that building and copy it to a different layer, which is going to be my general design layer. That way I don't delete or edit the building itself. I'm just going to have it on a separate layer and do all my work there. I'm going to do that with all of these elements that you see here. So at this point I can now freeze that building layer, and I have my working layer underneath. Now to start elevating entities, I'm going to use a handful of tools from the 3D data pull-down menu. We're going to start with just elevating the building itself by using a command change elevation. I use absolute. I hit OK, and I enter in the desired building elevation, which is 25, and select that polyline and hit enter. And that changes the building to elevation 25, which you can now see if you use the 3D viewer. You can now see that I have an elevated polyline which represents the building footprint. So the design for this site is just a 5-foot sidewalk, a 19-foot parking stall, a 24-foot wide two-way travel lane, followed by another 19-foot parking stall, which brings you to the edge of pavement or the edge of the pad. To design this, I'm going to be using a 3D polyline tool called Offset 3D Polyline. This operates very similar to a regular offset command, but I'm going to put in 5-foot offset for the sidewalk. But then to offset it, I can add a slope to it. So I'm going to use P for percentage of slope, and enter in a slope for that sidewalk. So I hit P for percent and enter the slope, which is going to be a -2%. And it offsets that and has built a polyline now, 2% slope from the edge of the building. You can take a look at those again with the 3D viewer, and you can see two lines. If you look carefully, one is lower than the other. And that's a real easy way to build and elevate design elements that can be then added into SiteNet here. Now, I want to add a vertical drop to that sidewalk, vertical edge down to the parking lot. So I am going to go back up and use the same offset command under 3D data, 3D polyline utilities, offset 3D polyline. Okay, and now I'm going to offset it horizontally by a very small amount. I'm just going to add in like about 1/100 of a foot. And then the vertical offset is going to be a -0.5. So that's going to create a 1/2 foot vertical drop in that sidewalk. So now if I zoom up real close, and again I can freeze that sidewalk layer now, and you can see two lines very close to each other. If I want to take a look at that in 3D, which I do, I select those three lines. You can see that vertical drop now we've built. So this is a great tool as you're designing to just go through and look after you've created some entities and elevated them. You give them a quick view in the 3D viewer. It keeps you on track as you're going along. So I'm now going to offset again and build that parking lane, or in this case I'm going to actually draw in the center of the driving lane, and I want that to slope 2% from the edge of the curb, which is that lower line that I just created. So the width of the driving lane is 12 feet, added to the 19-foot stall is a 31-foot offset, a -2% slope, and I've got that polyline now created downwards at 2%. I'm going to execute the command again and go another 31 feet, and this time up 2%. So essentially what I'm doing here is creating a trough in the middle of the parking lot to collect water. Again, take a look at this with the 3D viewer. You can see what I've built so far. Got a building, sidewalk sloping down and back up to the back edge of pavement. So I am now going to close out of this and add that layer to my design. Set layer for design. Pick any entity on that layer, and that general design layer is now in the surface layer library for design. I can now toggle off other, and so I have off other and existing, and the only things left are my design layer, which again gives me a clean screen to work on as I go through this process. So now I am going to modify the center line of the driving lane to direct runoff towards the front access road. To do this, I'm going to add a high spot to the rear of the building, the center line of the parking lot, a low spot in the front of the building, and then slope continuously towards it at a 0.5% slope. So all runoff water would now start at the high point in the rear and flow around the building in both directions and out towards the front. To accomplish this, I'm going to use another tool out of 3D data, and it is called Polyline Elevation Editor. When I execute this command, I select any polyline, and it converts it into a 3D polyline and numbers each vertex that exists on that polyline and displays the elevation of each. So you can see they're all the same right now, and it's flat. They're all 23.78. So I'm going to modify, starting from front to back, point number 2 to 3, and enter it in as a 0.5% slope. You can see how it modified the elevation of vertex of number 3. And I'm going to carry that across from 3 to 4 and make that flat by giving it a 0 elevation, or slope, I mean. So at this point you can see the back of the polyline is now higher than the front, and it flows from front to back at a 0.5% slope. My next step is to add a vertex. So I'm going to just use the add a vertex and use OSNAP midpoint and add a new vertex. You can see it drop right in there and assign an elevation, which is the same as 3 and 4. And I can now select number 4. You can see how they get renumbered when you add more vertexes. So I can select number 4 and change that slope from flat to go up 0.5% just by typing in a positive 0.5. It modified the elevation. You can check that by looking at from 4 to 5 is now also a 0.5%. I'm going to repeat that process and drop in another vertex at the midpoint of the front of the polyline. Snap to midpoint. It drops in a vertex there, and select number 2 and modify from 1 to 2 to be a negative 0.5%. I now have a polyline that slopes 0.5% all the way around the building. So I'm going to take another quick look at this in the 3D viewer and examine what I've done. So that is my basic parking lot design. So before I get into the access road itself, I'm going to go ahead and add this much into the design surface model. First, I'm going to project side slopes around the parking lot down to the existing ground. So to accomplish this, I'm going to use a command called design pad template. And as you can see by this dialog box, there is a lot that can be done with this command. For this exercise, I'm just going to use it to create 3-dimensional lines that get drawn on the layer pad. And so I'm going to turn off contouring the pad. Again, things will be drawn on the pad layer. And I am also going to turn off the option to write to a final surface, but it's good to keep in mind that that can be done, and you can save a separate surface model just for the pad itself. So I hit OK and select that outside polyline, the parking lot, and then I select the surface to project down to, which is the OG, original ground surface, and hit open. Fill slope, I'll put that at a 3 to 1, and the cut slope also at a 3 to 1. When I hit return, it projects the sloped lines down to where the connecting points will be to the original grade. So I now have those 3D lines drawn on the pad layer. It's still asking me if I would like to adjust the parameters and redesign the site. I'm going to say no for now. But just so you know that you can always come back and edit that same pad and change elevations, side slopes. You can move, rotate the pad. You can even balance it, which will give you a balanced cut and fill. So you can see I only have fill here, so I'm not going to do that. And you can still have the option to write that tin to a separate surface model if you want. So I exit out of that, and there are my pad lines, my slope lines. So I'm now going to add that layer, the pad layer, into my design surface library by clicking on and selecting that pad. As you can see now I have the design, I have the general design layer and the pad layer. So those are my design layers, and I'm ready to make a design surface. So I just simply click Make Design and it's done. So take a look at that. I look at the surface viewer, and I have 3 new tins now. These are the design tins. So again, in this case, similar to the existing, all 3 design surfaces are the same because I have not applied any sub material or topsoil or things like that. So in the 3D surface viewer, you have a really good opportunity to take a look at the surface as it is designed. And you can see the side slopes projected down accurately to the existing surface. I am now going to bring my attention to the access road. Now, understanding that these side slopes have been projected down from the pad, they are not taking into account currently the access road itself. So those are going to be superseded once I add in the access road. So I'm going to delete those lines, and I'm going to do so by using a command in the draft menu called Erase by Layer. And I can select from screen and just select that layer, anything on that layer. When I hit OK, it erases everything that was drawn on that layer. So I'm going to start the access road by designing the center line and adding grades to that. Currently that's a 2D polyline. So I also want to again copy that onto the design layer because it will alter the entity and turn it into a 3D line. So my current layer, I hit use current, and now I have that line copied onto my design layer. I'm going to turn off other again. So there's my center line. So I'm going to go back up into 3D data and again use the polyline elevation editor. I select that 2D polyline, and all the vertices are added to that polyline, and they're all currently at elevation 0. So what I want to do is pin the beginning and ending points and straight grade through that polyline. So I'm going to turn on 1, which you can see is up at the pad end, and then the last one is down at where it's going to be tying into existing. So I can select the last vertice, which in this case is 0.262, and use a tool called Pick Elevation from Surface. So I click on that and I select the original ground and hit open. Then it asks me to define the beginning point, which I am going to again pick that endpoint to, and I just use the O snap to snap right to the endpoint. So that's confirming the vertex that will be modified. And you can see it dropped in the elevation of 13.33 from the original ground. I'm going to do the same thing at the other end of it, but this time I'm going to grab the finished grade and again pick the endpoint, and now it has a grade that ties into the proposed tin. So I just selecting a different surface model, and it's straight graded from beginning to end at about a 2.5% slope. So I just hit OK, and that polyline now is elevated. So I can now go back again into 3D data and add in the sides of the access road by using offset 3D. And I'm going to put in a 12-foot driving lane and slope it down at a negative 2%. And select the center line, offset to one side and offset to the other side. Now I can look at this in 3D and take a look at what's happening at the intersection, and you can see that the edges of the parking lot are not tied into the access road. So my next step is to make that happen, and that will be to modify the edge of the parking lot to tie in to the access road itself. To accomplish this, I'm going to go back into 3D data and again use the polyline elevation editor and select the polyline that I wish to modify. So I'm going to use a command. So you can see we have all the vertexes labeled here. And I'm going to use the command add vertex at crossings. So I execute that and I select the polylines that I wish to add a crossing to. And when I do that, it adds a new vertex on the polyline that I had originally selected and drops in an elevation at that intersecting point. So the key here is to select the polyline that you want to modify first. If we go back and look at this in 3D, you can now see what we've done at that intersection, and the polylines now are connected at the edges. Now you can notice that the point on the center line of the access road is still not matching up with the edge of the parking lot, but I'm going to actually just eliminate that portion in a little bit, so I'm not going to worry about fixing that right now. The next thing I want to do is add fillet radiuses where the access road connects into the pad. So you normally just can't use a CAD fillet radius command for 3D polylines. So Carlson supplies a special tool to do that. And it is in the 3D polyline utilities. It is called fillet 3D polyline. You execute the command and you have two choices, an intersection or a corner. You enter in the radius, 35 feet in this case, and you select the two polylines similar to any other radius command, but then you tell it by picking which side you want the radius to appear. And it connects a 3D polyline and interpolates the grades between those two sections. Repeat this for the other side. Pick the two polylines, pick the side of the radius, and there is the fillet radius. Now, just using straight CAD, I am going to clean up this intersection by erasing the lines that no longer apply. You notice this command not only drew in the radius, it connected the whole thing as a single polyline. It is not closed, which I am now going to do by just using, again, a CAD command, close polyline. Now, I also know at this point that the center line is elevated so that I do not have a vertex matching in the center line of the road and the edges. So I need to drop in another vertex there to match that elevation, or I'll have crossing break lines with unmatching elevations. So again, the same tool, polyline elevation editor, select the one I want to modify, use that same command, add a vertex at crossing, pick the center line, and hit return, and it drops in another vertex, and it modifies that outside polyline. So I now have a complete closed polyline around the perimeter of all my design work. You can take a look at that again in 3D and check all the line work to make sure that it all looks appropriate. So you can see all 3D polylines are consistent and tied together. Now I can go back to my design pad template, same command I used before, only this time I will be selecting the entire design area, again projecting it down to the original ground, side slopes of 3 to 1. You actually get a calculated volume if for a report, so you have an idea how much fill we have on this site. And again, my design layers are already set up with the general design and the pad layer. So I'm ready to make design. But prior to doing that, my original boundary was all the way out to the exterior of the project. I now have a closed polyline that was created from the pad template, the design pad template, that I can use for a new boundary, a much tighter boundary, so I will have contour lines that end right at the edge of that perimeter. So I'm going to reset and create a new boundary. And this can be done as often as needed, so it's always a good idea to start with a larger boundary and then work your way in. But now that I have that, I execute the set boundary command again and select that new polyline. And now I'm ready to make design. I get a report that shows one crossing break line, so I have one small error in there of less than about 1/1000th of a foot, which is a side slope not quite connecting to the perimeter polyline. For 1/1000th of a foot, I'm not going to worry about that. So I can now take a look at my finished surface model. Grab Surface Viewer, and I can again look at that in the dialog box. I can shade it, get an idea, or look at wireframes. But look at how the road connects, the side slopes, and everything looks like it's built in there just right. So now I'm going to go back into my display options and turn on my other and turn on the design contours and hit OK, and there's my final contour lines. I can also turn off my design layers. So now I'm just having my presentation layers on the plan, and I can go do the same thing for my display options, go back into the existing contours, turn those on, and there is my final design with both the existing and proposed contours displayed.